Okay, Ben, this is what you missed when you weren't here. So we did chapter 8 kind of all in one, and we did an assignment on it, and then we took a little quiz. So we just hit the highlights. So here's some of the important things from chapter 8. The main thing we focused on was recognizing graphs. So here you have a linear graph. So this is f of x equals x, and this is what your graph would look like. If you have f of x equals negative x, it's going to go the other way. So it would be, if you have f of x equals negative x, it's going to go this way because you would have a negative slope then. So you just need to recognize that this is your positive slope and this is your negative slope. Okay? All right, the next one here is f of x equals x squared. So you're going to have a parabola. If you have f of x equals negative x squared, your parabola is actually going to be upside down like so. Okay? And again, this f of x, this represents your y value. So f of x is your function. It's representing your y value. So we have x, we have negative x, we have x squared, which is the parabola, and then we have negative x squared. All right, next we have absolute value. Right, anytime you have an absolute value, that means your x values are always going to come out, while x may be negative, your final value, which is going to be your y, your f of x, is always going to be positive. It's never going to cross down here into this negative y area. So you're going to end up with something like this. Okay, next we have square root of x, and so that one looks like this. One that's not listed on here that you need to know is, I feel like there's more, hold on. Reciprocals, that's not on here. Okay, so reciprocals are going to be f of x equals 1 over x. So those are going to look like this, where they're approaching your axes, but not touching. Okay, so there's your reciprocal graph example. Okay, let's see what else we have here. Okay, so here's a good example right down here of your positive x squared and your negative x squared. This is what happens to your absolute value graphs when you start putting more than just the x in the absolute value. It's just going to move it over. Okay, let's see here. Any more? Oh, I know one we didn't do. What if you have f of x equals like negative 3? Well, you can't even see what I wrote. There we go. Okay. Oh my goodness. There we go. It's backwards in the camera. Okay, so if you have f of x equals negative 3, that would be like saying y is negative 3. And how do you graph that? Okay, you're just going to come here, find your y value of negative 3, and it's just coming straight across like this. Or if you were to have, similarly, if you were to have a graph that said like x equals 5, you would come over here on the x-axis, 1, 2, 3, 4, 5, and this is where it would be. Okay? All right, I think that's all the graphs. Let me just make sure. Sorry for the quick flipping. Hang on. Okay, so let's go talk about some of our different functions and how to write them. All right, so let's see where we left off. Okay, if we did, hold on. Just trying to find the same ones I did for Jonah. One second. Okay. So if you want to write an equation of a line that's parallel to another equation, okay? So you're going to start out with like something like this. F of x equals negative 2x plus 3. Okay, that's our equation. And maybe you need to write an equation of a line that is parallel to this. So let's talk about the parts of this equation first. We know that we can change this to equal y, to say y equals mx, plus b, where m, oh good grief, there we go, where m here is your slope, right? And your b is your y-intercept, and this here, f of x, this is our y value. So if we were to graph this, it would look something like this. Okay, we would cross the y-axis at 3. 1, 2, 3. Our slope would be down 2 to the right 1, right? Because looking at your slope, put it over 1 so you have a fraction, and it's rise over run, and it's a negative. So we're going to go down 2 and to the right 1. And again, when we looked at our slopes, to get our negative slope, we know if we have a negative, like this would be negative 1. If we have a negative slope, we're coming this way, okay? So when we come down and to the right and down and to the right, that's creating this type of graph here. All right, there we go. So we're going to come down 2 and to the right 1, and down 2 more and to the right 1. Not drawn to scale because I'm on plain blank paper. Okay, so that's what our graph would look like. So now let's say we need an equation of this line, and let's say that it is going to pass through the point let's see. It's going to pass through the point 3, 4, 5. It's going to pass through the point 5, 5, 1. Okay, that's a 1. Okay, so we're going to write an equation of this line that passes through the point 5, 1. That is parallel. Okay, here's your symbol for parallel, or you can just write it out to this one. So we want an equation that's parallel to this one that passes through this point. So what we need to do is first take a look at our slope. And what we know about lines that are parallel is that they have the same slope, okay? So this is not going to change. But what is going to change? By looking at this, you can see that this line here is going to cross the y-axis somewhere else, not right here. So we need a new b value. So to find that, this is our x and this is our y of our ordered pair. We're going to go plug those in and find our new b value. So y equals negative 2x plus 3. So let's plug them in here. So your y is 1. 1 equals negative 2. Our x value is 5. We're going to drop this because this is part of this old equation line right here. We don't need this. We need the new place it crosses the y-axis. So we're going to drop that. We'll just put plus b so we can figure out what it is. So now we're going to solve. So negative 2 times 5 is negative 10. So we have 1 equals negative 10 plus b. So now let's solve it algebraically. Let's add 10 to each side. So we have 11 is b. So it's going to cross the y-axis now way up here at 11. So our new equation would say f of x equals negative 2x, same slope because it's a parallel line, plus 11. So that's how you write an equation of a line that's parallel. So what if we took the same information here and now we're going to write one that is perpendicular. Now we want an equation of this line over here that's perpendicular. Okay, all the way off the page. Let me zoom out a tad. There we go. Okay. So let's still have it pass through these 2 points right here. But now we want it to come this way, and we're going to have it intersect this original line here in a way that it makes a 90-degree angle. That's what perpendicular lines are. They make 90-degree angles. So let's come back up here. To get a perpendicular slope, you take the negative reciprocal. So you're going to switch the slope. So instead of it being negative 2, now you're going to, it's negative 2 over 1, right? So now we're going to switch these two numbers and change the sign. So since it's already negative, it's going to become positive. So now our slope is going to be 1 over 2. X plus, we don't know because we don't know the b. So we're going to take our points, 5 for x and 1 for y, and we're going to plug them in right here, and we're going to solve for the new place that our perpendicular line crosses the y-axis. So 1 for y, 1/2, and 5 for x, plus our unknown b. All right, so now we're going to multiply this right here. We have a fraction and a whole number. So an easy way to do that is to just take your 5 and put it over 1. So now you have 2 fractions. And when multiplying fractions, you just multiply straight across. So we're going to say 1 times 5 and 2 times 1. All right. Sorry, plus b. There we go. Okay, so now we need to get this by itself, our variable here. So to do that, we need to subtract this 5/2 to the other side. So now we have 1 minus 5/2 equals b. So to solve for this, what we need to do is take this here and turn it into a fraction. So 1 is equal to 2 over 2. So we have 2 over 2 minus 5/2 equals b. Okay, so now we can take 2 minus 5 because our denominators are the same. So we have negative 3/2 is b. Whoops, losing you here. So to rewrite your new equation, you would have f of x equals our slope, which is 1/2 x, this is our perpendicular slope, minus 3/2. And that's going to be your perpendicular equation. Now, obviously, my graph's not drawn to scale. But if we did it right and we did it on graph paper or we plugged it into Desmos, you would see that this is where it would cross the y-axis and that it would be perpendicular. And then your other one here would be your parallel line. Okay, so that is pretty much chapter 8 highlights. Any more highlights? We covered this chapter pretty quickly. I think that may be it. So I'm going to give you some homework on this. And then if you do the homework and you go over those graphs that I showed you, that's what's on the quiz. Like the first 6 questions are just identifying graphs, and then there's 3 or 4 questions where you have to find 2 parallel lines and 2 perpendicular lines, and that's it. Okay, hold on. Okay, Ben, here's a short assignment. So for 1 through 4, you're just going to write the equations. All right, so like the first 2 are parallel, so your slope's going to stay the same. And the second 2 are perpendicular, so you're going to use the negative reciprocal slope. All right, I will put this on Google Classroom also for you. So there's the first 4. All right, so 5 through 10, you're going to identify graphs. So here's 5 and 6, 7, 8. So you just write what it is. Like for this one, f of x equals what? So look at the graph notes, go back to the video if you need to. What does this type of graph represent? Here's 8 and 9, and then the last one is 10. So I'm going to put those up right now. Do that assignment, please, and upload it to Google Classroom, and that will take care of one of your missing grades. All right. Have a great weekend. See you next week.